Assalamu alaikum. Today, this is H-bridge circuit. Today, I'm going to present the H-bridge circuit in which I want to move motor in forward direction and backward direction. I made this circuit through the transistors. In my case, I use 4 transistors to make H-bridge. You can maybe use 6 transistors. I use NPN transistors and I attach diode. I attach these diodes as in this circuit. These diodes are used as a freewheeling diode. A freewheeling diode is that which protect the circuit against the fluctuation. If any fluctuation happens in the circuit, these diodes have to stop these fluctuations and protect the circuit. And I attach these resistors to maintain the voltage at the base side of the transistors. Each resistor I use at the base side of each transistors, and more I use motor inside the H bridge which attached to the uh, diodes inside the bridge. As you see, Q1 emitter is connected to Q3 base, Q3 collector, and Q2 emitter is connected to the Q3 collector, Q4 collector. As you see, then Q4 and Q3 emitter is connected to each other, and Q1 and Q2 collector is connected to each other. Through this, I create a bridge, which is called H bridge. And then at the input side, I attach PCB817 autocoupler. This autocoupler is used to stop flowing current in reverse direction when in the case if the fan is moving in backward direction through wind or some other reason, the current move in backward direction. That's why these autocoupler is used to stop damaging the component is used inside the insulation of PCB817 autocoupler. Inside such insulation, this consists of diode, uh, light dependent transistors, and LED. When input current start flowing, then LED turn on. Diode are in forward direction, current start flowing, and when the light emitted on the transistor, current start flowing. Diode is in forward, remove the current in forward direction. If in the case the reverse current is flowing from output side, then diode is diode is used to stop flowing current in reverse direction. Because the diode are in forward direction, if the reverse current flow, the diode stop flowing the current in reverse direction. And I attach the battery of this battery is 9 watt. I use 9 watt source, which is DC source. I attach positive side to the autocoupler A. This A is 1, which is positive, and 2 which is negative. C which is collector, and E which is 3, which is a emitter. Yes, emitter. You can see. Then when if we turn on switch 1, the circuit move in clockwise direction. If I turn on switch 2, the circuit move in opposite direction. As you see, in this is my H bridge circuit. Now start simulating it. Schematic running. You see, initially I not turn on any switch, the voltage will be 0 and motor will not running. If I turn on switch 1, then this motor is moving in anti-clockwise direction. If I turn off, then I turn on switch 2, then the motor start moving in clockwise direction. As you see, motor stabilizing, and then this is, you see, this moving in clockwise direction. Gradually the voltage increase and speed is increasing. Now if I turn off this, you see, then 0 volt circuit. If the switch is off, then the no current flow, circuit is off. Now let's check out the PCB layout. I print this circuit, I made PCB layout. Do you see, this is PCB layout of this circuit, and Q5 and Q6 is used here. There I attach switch, that in the inside of switch I use transistor to fix some switch, some buttons, sorry. And R3 is used where the V source attach source, and one I attach one or two jumper wires. You see this circuit, and I print this circuit
through export graphics and print on PCB sheet.
Now I attach the Arduino with my circuit, which I program this code to my circuit. This this loop is for the second delay and the time wait. This is for output. I applied void. This is a function program we apply. The E&D reverse current 12 when reach. This happened on 13. Then this forward and 11 to 11, and now you see circuit. This is my circuit. This is working. Only I attach this forward pin and reverse pin. Forward I give plus 5 volt, and reverse this negative 5 volt. This switch, when I on this switch, this move in negative direction. Then I turn on this and off this, then they move in forward direction. This when I turn on this switch, this move in reverse direction. If I turn on this one, then they move in forward. This is forward pin. They enable this current to flow. If I enable this current to flow, then they move in positive direction. If I enable this one, then they move in negative direction. Now you see, I run this simulation. You can see they are moving in anti-clockwise direction, negative. Little bit slow, but this is moving in negative direction, as you see. You can see if I turn off this and on this one, then they move in clockwise direction. This is the source code, and this is our circuit. This is auto bench circuit, which I attach Arduino and some configuration. I do a program to decode it, run after 1 second or some, maybe I in my programming I delay of 1 second. I add this is my automate circuit. Upper side to see my roll number. Now this I created this another one circuit. This is maybe not a good one, but I created this another circuit in which I use 4 transistor of edge bridge direct, no diode is used, and this is in the input side. In the reverse side and forward side I attach one resistor for the switching, and the resistor I mainly use for the switching. And you see, this is in input side, this if I then simulate this one. If I turn on this one, they move in anti-clockwise direction. If I turn off turn on this, then motor in clockwise direction, and resistor and capacitor uses some stop fluctuation and move stability to move current in motor. And you can see I also created the PCB layout, but this is not a best circuit, that's why I consider the auto. In this circuit, the transistor is used for the switching as switching device. Transistor is switching device 2 and triple two. This is I use this because this is available easily in market. This is our final circuit. You see, this is a working circuit which I consider and made this. Further, I uploaded the video of the working circuit which I created on the PCB sheet. You have further I will tell, and I also test this circuit on the breadboard. You can further see it. I see the difficulty is that one. First, my circuit is not working, then with the MOSFETs, I use the MOSFET that are expensive and not available in the market. That's why I considered this circuit. These all components are available in market, but it's not a high switching device, but that is work better, not much better. MOSFETs are much more better, but this I consider this one because these are available in markets and not much expensive.
Primary circuit, we move motor clockwise and anti-clockwise. We use two buttons for one press they move in clockwise, and other button we press they move anti-clockwise. The two autocoupler are used to reduce the damage and control and stop flowing the current in backward direction. These are resistors, and further we use H bridge and freewheeling diodes to limit freewheeling diodes with transistors. From this button they are moving anti-clockwise, and from this clockwise or anti-clockwise. This we use a jumper wire for motor. We have motor attached. So this is my roll number 221724 Mohammed Ali soldering. This is our PCB sheet on which we print a circuit. First, there consist of 3 steps, maybe 3 steps or 3-4 steps. First is that cut the PCB sheet the size on the size of the paper on which the circuit is printed through the Proteus software. First I cut the PCB sheet, then I put a photo paper on which the circuit is printed, then I mirror the circuit or print the circuit on the PCB sheet through the iron by pressing them. Then the circuit has been patched, mirrored or attached, mirror or pasted on the PCB sheet. After that step, when the PCB sheet comes to their normal position, then FeCl3 chemical is used to remove a copper from the other side. Instead of tracks remains of the circuit track remains. After that step, when the track remains, clean the circuit through the petrol or some other. Then next step is drilling. Etching is done. When etching is done, etching is a process when we wash, or etching is a process when we press or print a circuit, mirror them. This is etching process. Next, washing, and then next is drilling. Drilling is a process in which when the component are being fixed on the PCB sheet, the some drilling are required. The next process is drilling. Drilling is done by the drilling machine. Then small holes drilled, then attach component on their position. After attaching the component, the next step is do some soldering. Soldering is a process which the solder is the device from where we solder the component by a solder wire. When the R component is attached, first before the attaching the component, test all the components, are they are working or not. Check their resistance, and check all these stuffs, and check the component is working properly. After the confirmation that component is working properly, then patch on them on the PCB sheet through the soldering. When soldering is done, then next step is test circuit. If any problem, then you can check the each component properly, check the track are completely not broken, not shorted, etc, such like that stuff. After that, if your circuit is working, then that I also test on the my circuit. In my circuit, one problem is facing that two wire of the wires not the resistors little bit are connected by the autocoupler. They shorted them, that's why my circuit not working. Then I do some changing, and keep awaying the resistor from the autocoupler. Then it start working and no short the circuit, and the circuit completely working. That's it. The process whole after whole step, the PCB sheet are made it are being on your front side. This is my PCB sheet. All components are properly packed. Thank you. This is breadboard testing. First I test on breadboard, then I simulate or on the PCB sheet or printed on the PCB sheet the circuit is working properly. From this project, the conclusion that we work on this project, we learn a lot of things from this project. We know how to etching, how to do etching, how to drilling, a whole process of making PCB sheets, stuff like that. We work different things from this project. We learn a lot of things, how to work in industries, how PCBs are made, how working in Proteus, how to make simulations, how to make a PCB layout, and how to code a Arduino. This is a final circuit. This is not a final circuit. We made only a without Arduino manually transmitted circuit, but in next further we also create the circuit through the Arduinos, but on PCB we only make a circuit by manually transmitted through the manually controlled by the two buttons, one for forward and second for reverse. If in further the Arduinos are used under industrial application, the Arduinos are used to control automatic to program. If you want to run a circuit after 1 second, you can be code them or run before or move in forward direction after 1 second, move in backward direction after 2 seconds. You can change accordingly by Arduino. Arduino is one of interesting component. Thank you. That's it from my side to this project. Personally, I learned a lot of things. Thank you.